section, we're going to look at electrolytes and how they bond and what valency is. Now, again, some of you will have a very strong knowledge base of this, so I'm going to try and explain this as simply as possible for others. Okay, so when we look at water, whether it's body water or water in a bottle that you've purchased, it's seldom just water. It has other things in it, substances. So some of these substances dissolve or dissociate and we produce electrolytes. So some examples of electrolytes down there are sodium chloride, sodium bicarbonate, or sodium by itself. And so anything that ionizes in water and capable of conducting an electrical current is an electrolyte. Some things that we can put in water don't dissolve or don't separate are non-electrolytes. When electrolytes do dissociate in water, when they dissolve in water or dissociate, they form what we call charged particles or ions. And so an atom or a group of atoms will have an electrical charge. It can either be positive or it can be negative. So you can see sodium has a positive charge, chloride has a negative charge. So let's look at why this happens. When we look at atoms overall, we look at the fact that there's a nucleus, okay, a nucleus, and in the nucleus are two things: neutrons, which have a neutral charge, and protons, which carry a positive charge. Circulating around the nucleus is electrons, which carry a negative charge. Okay, there's another rule to think about here. I'm just going to go to the next slide. It's about valency, and valency is how the electrolytes are organized around the nucleus. So this is sodium. You can see it has 11 protons right here, and 11 electrons. But there's a rule in how they're organized. The first shell always has 2, and then 8. Okay, and to be stable, we want to have 8, or I say happy. If the outside shell is full with the amount of electrons it should have, like 8, then it's a happy, if you will, because it's satisfied. However, you can see here we've got 1 left over. So this is why we want to stabilize this. Okay, so let's take a look and see what happens here. Okay, so this is just another example. You can see that hydrogen has 1 circulating. Helium has 2. That's pretty stable and happy because its outer shell is stable. Lithium, we looked at before, has just 1 circulating. So both of these are going to seek valency to be stable. So when we're talking about stability, what we're talking about is how are anions, which carry a negative charge, and cations, which carry a positive charge. So negative over here, positive over there. When atoms start bonding together, they're seeking stability. So that means that outer ring is going to be stable, of having 8 in it or 2 in it, depending on where we're at. So in order to do that, they either gain or lose or share. Okay, an atom that gains an electron, because it's going to gain 1 to be, it's going to carry a positive charge. And an atom that loses an electron will have less negative electrons circulating around, so therefore it's going to have a positive charge. So a negative charge is something that's gained an extra electron. So we've got more electrons than protons. It's called an anion, a negative ion. And then if you look at electrons that lose, they have more protons than electrons, so they're positively charged, or a positive ion. Now I know that's very simply put, but that's really what you need to get here. Okay, because in the body, when things are moving around, we want to make sure that our various electrolytes are going to be stable. So what this is showing you here is sodium. Okay, remember it's got 2 here and 8 here, and so it's got that 1. So it zips off and finds some place to go. And chlorine just happens to have 7 in its outer ring, so they're a good combination. I always say sodium and chloride love each other. Okay, and they will do that, and they will become stable. So this is stable because this has 8 and this one has 8 as well. So because it's gained an electron, this is going to be negatively charged. Because it's lost one, this is going to be positively charged. Okay, and just another example of bonding here. We've got two hydrogen ions coming together. Two hydrogen atoms coming together to make a molecule because they're going to share. Okay, so these two will satisfy both of those atoms. Just another example for you to look at, oxygen, and what they do is they share as well. Okay, so you can see that oxygen has 2 in its first one, 6 in its outside one. So along come 2 hydrogen, so they share theirs to make 8. So again, we're just looking at the basic structure. What's a cation? Cations are positively charged, meaning that there's more protons than electrons, and in our body, sodium is the number 1. Okay, there are others, potassium, calcium, hydrogen, they're all positively charged as well, but sodium's number 1. Anion, so this is a positive charge here, anion, a negative charge here, and chloride's the number 1 in the body. Other examples include bicarb and hydroxyl ions as well. So that's just a brief overview of that. I often refer to electrolytes as being happy through bonding. So sodium is going to be happy because it's got stability in its outside ring when it gives one away, and so on. So they're always trying to achieve their valency or their outer shell to be charged, to be satisfied.